Okay, so for day 4's daily challenge, we have a review about the polygon. And yesterday we have the review of the congruent triangles. And today let's move on to see another very important part in the geometry part, okay? So the first question, we have PQRS is a parallelogram. And we need to find all the unknown angles and the sides in it. Okay, so this question, it's not hard. So it's only a question that helps us to review about the basic properties of quadrilateral. Okay, and before that, let's have a quick recap that quadrilateral, it's like quadrilateral with both pairs of the opposites parallel to each other. And also the basic property is that the opposite sides of the parallelogram are parallel and equal to each other, and the opposite angles are equal to each other. And also another very important properties of parallelogram is that the diagonals of the parallelogram bisect each other. Okay, and here we need to find all the unknown angles and sides. So we currently have like PQ equals to 15 and PS equals to 8. And so based on the properties, we know the opposite sides are parallel and equal to each other. So we can have A equals to like PS equals to 8. And we can have B equals to PQ equals to 15. And for the X, the opposite angle is the angle P. So we have it equals to 80 degrees. And for the Y, it equals to, so we have the PQS equals to 30 degrees. And so as the QSR, it also equals to 30 degrees. And we also know X equals to 80 degrees. So we can have Y equals to minus 30 degrees minus 80 degrees, which is 70 degrees. Okay, so this one is relatively easy. And let's quickly move on to see another question. So it's also in the parallelogram ABCD. And what's the possible value of the angle A over B over C over D? And so since we know the opposite angles of a parallelogram is always equal, so we may have so we must have the angle A equals to the angle C, and the angle B equals to the angle D. So the only correct choice is C, okay? So if that's the case, it should be all the angles should be 90 degrees, right, guys? So pay attention to the sequence here, okay? So that's another question, help us review about the basic properties of parallelogram. Okay, and the third question, it's also in the parallelogram ABCD, we have the angle B equals to 3 times the angle A, and we need to get the angle C. Okay, so here, for B and A, we know that they're what? What's the relationship between B and A? Can you tell me? Type in the chat box, guys. There are 4 students joining today's session. Okay, for Eric, Gary, Katie, and Yan, what's the relationship between A and B? Okay, not the answer, Gary, but the relationship between A and B. Yes, thank you, Eric. It's 3 over 1, and actually A and B, they are interior angles on the same side, right? And for the interior angles on the same side, the sum of these 2 angles should be 180 degrees, right? So, and we also know the ratio between the angle B and A. So we know that angle B plus angle A equals to 4 angle A and equals to 180 degrees. So we have A equals to 45 degrees, right? And based on the properties, the opposite angles are equal to each other. So angle C equals to angle A equals to 45 degrees. Okay, choice D. Okay, that's for the third question. Let's move on to see the key question in today's challenge, okay? So this question, there's 3 parts. It asks us to find the area of the following. And I see in the WeChat group, some parents ask me that, what's the first question? Why it's like it gives a radius of the square? What does that mean? Okay, so let's have a review of the regular polygon here. So if that's the regular polygons, that should have a center and also the radius. So the center is the center of the circumscribed circle of the regular polygon. And the radius is the distance from the center to a vertex, okay? So regular polygons, it's a polygon that is direct, angular, and equilateral. So that's why for the first part of this question, it gives us the radius, okay? And let's see these 3 one by one. So, and the first one, it's a square with a radius of 10K. So the radius actually is the distance from the center to a vertex, and it's also the radius of the circle, okay? So now the square is circumscribed by the circle. So we have the radius as 10K. Okay, so if the radius is 10K, then we should have this one. So the relationship is actually 10K over root 2, and the side of the square actually is twice of this. And we have the area, so we square it again, we get 200K squared, okay? So pay attention to this question about the regular polygon, okay? And the second one, a regular hexagon with side lengths of 2A. So for 2A, we know that as it's a hexagon, it has 6 equilateral sides. And so which means this should be 6 degrees, and it's equilateral triangle for each of the triangle within it, okay? So we can get, if the side length is 2A, then if we have a line perpendicular to the side, then half of it should be A. And as it's an equilateral triangle, we can then have the radius as 2A, and also the height is root 3A, okay? People are coming in, okay? So we can have, so for each of the equilateral triangle, the area is 1/2 times the base, which is the side length is 2A, and the height is root 3A, and we has 6 of such equilateral triangles, so we need to times 6, and so we can get the final answer is 6 root 3A squared as the area of the regular hexagon, okay? Okay, let's see the third one. A regular octagon with side lengths of 8. So if we want to solve this, let's first see the graph here. And an easy way to solve it is that we can complete this octagon to a square. So, and then it would be easier for us to get the area of the octagon by using the bigger square and minus 4 right triangle on the corner, okay? So let's see if we have the side length as 8. So we know that as it's an octagon, so for each of the angle, it's 45 degrees, okay? So we use these 362 divided by 8, so which is 45 degrees. And also, this one is also 45 degrees. Okay, so the right triangle, we can have the side as what? Okay, let me see. So Gary, not 64. Okay, let's see how can we solve it. So if the side is 8, then we can have the triangle side as 4 root 2, okay? And then, so for the bigger square, the side should be 8 plus 2 times 4 root 2. And we have it area as square it. And don't forget to minus the 4 triangles on the corner. So we use 4 times 1/2 times 4 root 2 squared. Okay, so we have 2 sides equal to 4 root 2. Okay, so the final answer is 128 root 2 plus 128. Okay. Okay, it should be 128 plus 128 root 2. Okay, Gary, instead of 64 plus. Okay, so that's a question. Help us reviewing about the regular polygon, okay? You're welcome. Okay, let's see the next question. So as shown in the figure, the parallelogram ABCD, we have DB equals to DC. Okay, so DB equals to DC. So therefore, we know that DBC equals to DCB and equals to A, which is the opposite angle. And as we have A equals to 70 degrees, we can have the DBC also at 70 degrees, and the BCE is 90 degrees minus 70 degrees, which is 20 degrees, okay? Okay. So this one is also easy. And let's see another question. Which of the following conditions below enables one to deduce that ABCD is a parallelogram? Okay, so this one also easy. How can we prove that? So choice D, okay. So there are several ways that we can prove it be a parallelogram. So what the four ways that we can prove that? Oh, 5 way, okay, actually. So first, if we have both of the opposite sides are parallel, then the quadrilateral should be a parallelogram. That's the first way we can prove that. And, oh, sorry. My app had stopped. Okay, let me share it again. Okay, so that's the first way. If we have both pairs of the opposite sides parallel to each other, and if we have both pairs of the opposite sides are equal, then we can also have the quadrilateral as a parallelogram. That's the second way. And the third way is that if both pairs of the opposite angles are equal, then we can prove it to be a quadrilateral, okay? Okay, people are still coming in. And that's the third way. And also the fourth way is that if one pair of the opposite sides are equal and parallel to each other, then we can prove that the quadrilateral is a parallelogram. And there is a fifth way, which is if the diagonals of the parallelogram bisect each other, we can then prove that it's a parallelogram. So currently we have the opposite angle equal to each other, and also like there are two opposite sides parallel to each other. Okay. So a question help us review about how to prove the parallelogram. And let's see two other proving questions, okay? So as shown in the figure, we have the quadrilateral ABCD as a parallelogram. PQ are 2 points on the diagonal BD. So BP equals to DQ. We need to prove that AP equals to CQ. Okay, so for this question, we can draw AO, we can connect AO, and we have it intersect with BD at, let's say it's point O, and let's connect also AQ and PC here. Okay, and since the quadrilateral ABCD is a parallelogram, we can then have the, so since quadrilateral ABCD is parallelogram, we can have OA equals to OC and OB equals to OD. And since we have the BP equals to DQ, so therefore we can have the OB minus BP equals to OD minus DQ, so which is OP equals to OQ. And as OP equals to OQ and OA equals to OC, so we can have the APCQ is also parallelogram, okay. And then based on the properties, we can have AP equals to CQ, which is the opposite side. Okay. So this is a question, proving question, okay. So you need to pay attention to the steps. Try to have the complete steps, okay? Okay, the last question. As shown in the figure, we have a line EF. It intersects with AD and BC at point E and F. So respectively, and they bisect the BD at O, the intersection point of diagonals of the parallelogram ABCD. So it is given that G and H are midpoints of OD and OB respectively. So we need to prove that the quadrilateral EHFG is a parallelogram. Okay, so let's first see, as ABCD is a parallelogram, we can know that this AD, so AD parallel to CB. Okay, and therefore we can have the angle DAC equals to the angle BCA, and we can have the angle, okay, EOA equals to the angle FOC, and we also have OA equals to OC. So by what? By ASA, we can prove that the triangle AOE congruent to the triangle COF by ASA, okay? And then we can have the EO equals to FO And since we have OB equals to OD, and we know H and G are both the midpoints of OD and OB, so we can have OH equals to 1/2 of OB equals to 1/2 of OD equals to OG. Okay, so OH equals to OG and EO equals to FO, and therefore we can have that EHFG is a parallelogram. Okay, so we have them bisect. Okay, typo. Okay, so that's for this question. Any questions, guys, for these two proving questions? So remember, there are 5 ways we can prove that quadrilaterals are parallelograms. And here, the last question, we use that if the diagonals of the parallelogram bisect each other, since we have the OE equals to OF and OH equals to OG. So they bisect and then it's a parallelogram, okay? Okay, if no questions, that's for today. And there are no daily challenge through the weekend. The day 5's challenge will begin on Monday. So hope you have a good weekend, guys. And see you next week, okay? Yeah, thank you. Bye, you're welcome. Okay. You're welcome. Bye, guys.